Welcome back to your physics notes. Today we're going to talk about one of the most fundamental and important forces that we deal with, and that is friction. So let's take a look at friction. Let's go back and review some basics. So first of all, there's two types of friction. You have static friction, which is when the objects are not sliding relative to each other. And this is a tricky one because static friction is not actually an equation. So static friction is an inequality. So it's always less than or equal to the coefficient of static friction times the normal force. So this means that you could have a situation where it's zero, it's equal to zero, or you could have any range of amounts up and including the coefficient times the normal force. To solve static friction problems, they are harder. You need to use Newton's second law to solve these problems. You cannot just plug into an equation. Now, kinetic friction is easier, okay? This is when the two surfaces are sliding relative to each other. And the reason it's easier is because once this starts happening, it is no longer an inequality, now it's an equation, and you have the coefficient of kinetic friction times the normal force. So it's easier. You can plug and chug on this if you want to, if you know what the normal force is and you know what the coefficient is. Now, another thing to keep in mind, just from a conceptual standpoint, is that in general, the coefficient of static friction is always a little bit greater than the coefficient of kinetic friction for two surfaces. So if you picture yourself moving a refrigerator across your kitchen floor, it's a little bit harder to get it started when it's stopped. Once you get it sliding, you have to apply slightly less force to keep it moving than when it was at a dead stop. Okay? Now, to look at this, let's look at an AP problem. So here is a Newton's second law problem from the AP exam. And you can see, I think you've seen this diagram before, it gives me a description of two masses, okay, one suspended from a string and not touching anything, and one on an inclined plane and attached to the string. They give me lots of information here. They give me the coefficients of friction, they give me the angles. The first thing they ask me is what is the tension in the string? Well, if you think about this, there's two places where there's tension. There's tension on this block, and there's tension on this block. And a lot of times in the AP exam, you want to take shortcuts and you want to think about what's the easiest way to find something. Well, looking at this situation, there's tension applied in both of them, and there's no motion, so I know that Newton's second law should be equal to zero. I get to pick which block I want to look at, and I challenge you to answer which of these would be easier to find tension. You can see that in this one, you're going to have angles, which is going to involve a little trigonometry. You're going to have a normal force. You're going to have friction. In this one, there's no surface interaction, so it's much easier. So if you look at this 10-kilogram block and draw a free body diagram for it, you know that it's at rest. It tells you that in the problem. There's no sliding yet. So I draw a free body diagram. The interactions are the interaction between the block and the earth, pulling it down. That's the weight, and the tension. And I know that the sum of the forces in this case are going to be equal to zero because there's no acceleration. So that means that T has to be equal to the weight of that block. So for part A, quite simply, I can find an answer. It's a 10-kilogram block. So 10 times the acceleration due to gravity is going to give me 100 newtons. So there's my answer for part A. Congratulations, you just earned 3 points out of a possible 15 on the AP exam. Now, on the diagram below, draw and label all the forces acting on the box that is on the plane. So they give me this little picture. Now, if I want to draw forces on this, put a dot. I have the weight of the block. I have the tension in the string. I have the normal force, always perpendicular. Friction can either point up the slope or down the slope. It's always parallel to the slope. In this case, it's preventing the block from sliding, and the block wants to slide up, so your static friction would be like that. So there's your free body diagram. Remember, you don't draw anything else on a free body diagram that they're going to grade. You leave it like that. Part C now says determine the magnitude of the frictional force acting on the box on the plane. I now need to look at my free body diagram as a force resolution diagram. So I'm going to go ahead and do it again. This seems like a pain in the butt, and it is, but that's the way you have to do it on the test. You do not want to draw vector components on your free body diagram. Static friction. I have to break this guy down into his components. That is whatever that angle is of the inclined plane. So this becomes mg cosine of that angle theta. This is mg sine of that angle theta. And now I write Newton's second law, and they want me to find the frictional force, okay? So let's go ahead and define my frame of reference. This is positive x. This is positive y. I just make it match the plane. So if I write Newton's second law for the x dimension, I get t, which is in the positive x dimension, minus whatever is in the other dimension. I have mg sine theta, and then I have minus static friction. And since the block is at rest, there's no acceleration. That is equal to 0. Now you can see that what I didn't do here was try to take a shortcut, and you remember that kinetic friction is equal to the coefficient of kinetic friction times n, and sometimes people will try to use this to solve this problem, and you will be wrong, because this is not kinetic friction, it's static friction. And you remember that static friction is an inequality. It's the coefficient of static friction times the normal force. It's not necessarily equal, so you can't just plug in mu and n and get an answer. You have to use Newton's second law to find it. So now if I rearrange this equation, I get friction is going to be equal to, I'm just doing my algebra here, t minus mg sine theta, and then ask yourself if you have enough information to find an answer. Do we know what t is? I found it over here in part A, and nothing has changed in the situation, so I know what that is. Do we know what m is? They give it to me. It's a 10 kilogram block. And do I know what theta is? It tells me it's a 60-degree angle. So now all I have to do, coefficient of static friction is equal to 100 newtons minus mg, which is 100 newtons, times sine of 60 degrees. And you plug that in a calculator, and you should get a numerical answer. Now, for part D, it says determine the amount of mechanical energy. You don't know how to do that. And determine the blah, 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 blah. So you don't know how to do the rest of it. But I can make up a second problem instead of these. And I say, so now the string is cut. This is sliding down the hill. Now determine the amount of kinetic friction acting on the block. Well, if I cut the string, now let's look at my free body diagram. So now there's still weight pointing down. There's still a normal force. But now which way is friction? The block is going to be sliding down the hill. My velocity is that direction. So friction is going to try to prevent that. And my kinetic friction is going to be up the hill. So now if I want to know how much kinetic friction there is, there's a couple different ways I can solve this problem. I can look at this, and I know that this is 60 degrees. So this is mg cosine theta. Well, that's 60. And then this is mg sine of theta. I know that kinetic friction is an equals. It's an equation that's equal sign. Coefficient of kinetic friction times the normal force. So I can just simply look at this. If I know what this is, and I know what this is, I know how much friction there is. So I can say coefficient of kinetic friction is equal to, friction is equal to the coefficient of kinetic friction times the normal force. And if I look in the y dimension, I see that the normal force has to be equal to mg cosine theta. And now I should also be able to get a numerical answer by plugging those in my calculator. So when you have static friction, you have to use Newton's second law to find an answer, because it could be as little as 0, could be a maximum of mu times n. When you have kinetic friction, it's easier because it is always equal to the coefficient of friction times the normal force. Now, sometimes you might not know what these are, and you have to use Newton's second law anyway, given the acceleration of the block. But either way, that's how you solve friction problems. Adios.